regular contributor to the Astro Imaging Channel on YouTube. He's an Astronomical League AL Master Observer, and he's a veteran speaker at many events and locations such as the RTMC Astronomy Expo, Nightfall, Texas, Central New Zealand Star Party, Sequoia National Park's Dark Sky Festival, Woodland Hills Telescope programs, Orange County astronomers, and astronomy clubs throughout Southern California. So welcome, Alex, and thank you for joining us.
Thank you. I'm going to start sharing my screen here. And if you don't mind, we're just going to go right into it. I had forgotten you'd gotten my biography there. It's always weird to hear that stuff about yourself. We're going to be talking tonight about 5 astroimages that destroyed the world. And I don't want you to get too frightened. I mean, we are destroying worlds here, but think about how much we love taking astro images, taking these pictures, looking at them. This one was one of my favorites, about 10 years old, a narrowband. And for a while, it was used as the logo for RTMC. But you know, there are other astro images that have a lot more effect. And in context, they can actually, they can make real changes in the world. And we're going to be talking about some astro images that really made some changes in the world here. And when we do, I think you're going to find out that, well, there's some surprises out there. How just a little bit of a thing can change everything around. All the things that you believed, all the things you held dear, can just be blown away very quickly. So let's start talking about them. Oops. I'm using 2 different computers here because of the vagaries of how this all works. So let's get to coordinate. People have been taking astro images of the heavens for forever. One archaeologist claims that this figure, this carved in mammoth bone, has pip marks on the back side of it that represents the constellation Orion, the giant. This would make this 35,000-year-old bone the oldest astronomical image that we know of. And you see these pips here? If you subtract the number of marks from 365, the length of a year, you have the number of days that Orion's Betelgeuse is in the sky. So it's actually an astronomical calculator. And by the way, the archaeologist who claims this also says that it represents the number of days that a woman is pregnant. So it's both an astronomical calculator and a pregnancy calculator. Now, you can take those claims for whatever they're worth, but no archaeologist doubts that the patterns here in the caves at Lascaux really do represent the Pleiades, the Summer Triangle, Taurus, the Bull. They're pretty unmistakable. Our ancestors were looking up and they were recording what they saw. And astro images show up today as well. The second most famous painting in the world, according to my internet clickbait source that I consulted, is Van Gogh's Starry Nights. So that's second only to the Mona Lisa. So no doubt we've been making images of the heavens of one kind or another for many, many years. How about you say, should we be limiting to astrophotography? Astrophotography is using chemical or now digital means to record what is normally seen by the human eye or what might be seen by the eye. 2 very accomplished astroimagers, Bob Gendler and Jay Gabaney, put out a book not too long ago. It's a beautiful book. It takes one back to the first generally recognized astroimager, Draper's Moon, and all the way through A.A. Commons M42. This is the first astroimage that shows stars fainter than the eye could see, all the way up, of course, to the modern things that you got from the Hubble and the other radio telescopes and others. There are 100 astronomical images that changed the world, and included many images made by chemical or digital means that reproduced what is transmitted through the visible light and other electromagnetic waves like radio, X-wave, gamma rays. I'm also going to include any images produced with other means, including carving and sketching. But as you will see in the next few minutes, I question whether Gabaney and Gelder's choices were of images that changed the world, or simply mark developments in astronomical imaging. Their book, it's beautiful and it's intelligent. It's a description of the history of astronomical images and imaging. But I think you'll see that I have a different perspective of change the world. What do I mean? Let's look at another beautiful, sometimes horrific book put out by Life magazine. Remember, Life magazine are the people who, for the last century, told the history of the world in weekly magazine photo spreads. They chose 100 photographs that changed the world and put them in a book. Yeah, they have the first photo. It certainly changed the world. I mean, everybody with the cell phone camera owes something to Nipsey and his early efforts with the daguerreotypes. And who does not remember that kiss at the end of World War II? And for those of us who lived through the 60s, who can forget Duncan Cameron's Canadian seal hunt? These are all photos that we've seen and we remember. But did they change the world? My definition of influential, it's a picture must be more than memorable. To be influential, it must change the world. Let's contrast these two. On the left, an unknown sailor grabs an unsuspecting nurse, gives her a big smooch. The war's over, but the picture didn't end the war. It just marked symbolically after the fact that the war was over. Nobody changed what they were doing or how they thought because of this picture. On the right, however, many people, they're already picking up the vibes of the environmental movement. They become incensed. Seal fur trading stopped in many countries. Laws were passed. International agreements were signed. Fashion changed. The world changed. And in some part, due to this photo. The sailor's picture was memorable, but not influential. The execution of the baby seal was both memorable and influential. I would contend that the shaman, earnestly and devoutly decorating the cave, was recording what he saw, but everybody else saw it, and nobody disputed it. People and things did not change because of this picture. Those seeing Van Gogh captured the scene out the window in southern France was relating to what anybody else could see, although his psychosis did make it a little more striking. But nobody wakes up after visiting MoMA and seeing this painting and changes their life because of this painting. Even the stunning pillars of creation did not make the world rethink their priorities. Yes, they're all memorable, and yes, they have marked turning points in archaeology, perhaps, or painting, or even imaging, but they didn't change lives. The world was better for their images, but it didn't change. And to be considered influential, an image must have influenced something. To be considered most influential, the image must have influenced the world, not just the history of imaging, not just some findings in archaeology, not just astronomy or science itself, not just marked a turning point in history, but it must have helped to cause or to speed an inflection, a change in the direction of history or mankind as a whole. The image illustrated something not previously seen, not seen clearly enough to be understood. Did the world know more after the illustration? Was the old world somehow destroyed? And finally, while I'm going to require that the image record something that was transmitted along some spectrum of electromagnetic waves, visible, X-ray, radio, whatever, I'm not going to restrict myself to photographic processes, but I'm going to include some significant drawings. Our first image destroyed the ancient world. In general, the Earth was the center of the universe. Maybe Jerusalem, maybe Rome, maybe the Pharaoh, but definitely everything else revolved around good old Earth. And everything moved in perfect circles. As a matter of fact, everything except the Earth itself was perfect and unchanging. The moon was smooth and perfect. These things that did appear to change, like the wandering planets, which included the moon and the sun, were controlled by the gods. And the gods also sent weird messages through eclipses and comets and occasional strange things that weren't static. And actually, for the people of the times, that worked pretty well. It explained things. Much of this made perfect sense to people accustomed to following the authorities like Aristotle and Ptolemy. These guys knew pretty much everything there was to know. They were the authority. From them, you found out the first principles, and applying deductive reasoning, pure logic, reasoning from what Aristotle and the likes told us, you could describe the world. They believed in the authority of the ancients, that the guiding principles were already discovered and unchanging, that they could deduce what there was to know from that authority and those principles. Remember the story attributed to Francis Bacon in about 1605. He writes that in the year of our Lord, 1432, a grievous quarrel erupted among the learned brethren about the number of teeth in a horse. Arguments raged bitterly for 13 days. None of the ancient books and chronicles could answer the question. On the 14th day, a youthful but devout friar asked why the learned men did not just look in the mouth of a horse. Their dignity of the learned friars was hurt by being asked to do such a base thing, and they beat the young friar nearly to death, and they cast him out. He and his unheard of ways were unholy and contrary to the teachings of the Father. And after many more days of strife, the dove of peace finally descended upon the assembled friars, and they declared together that the number of teeth would for everlasting be an everlasting mystery because of a grievous dearth of historical and theological evidence thereof. The Earth, we can't cover all there is to do with medieval mythology and cosmology, but to highlight, the Earth is the center of the cosmos and everything else moves around it. Furthermore, all motion follows perfect circles. Now, this was demonstrably impossible. It had been known for some time because certain planets were known to reverse direction at times as they circled the Earth. However, Ptolemy had a logical explanation that fit these observations. Planets were moving on perfect circles, as the perfect circle itself was moving in a perfect circle. And this made, from our perspective, the planet appear to reverse directions. Retrogrades, deferents, equants, epicycles, they all worked fairly well to tell where any of the wanderers could be seen in the sky. Part of the ancient and medieval system was that everything in the heavens was static and perfect. Note the perfect moon which Dante and Beatrice are traveling. No blemishes, no hills, no valleys, none of what we would call craters. Well, they made sense to the medieval because none other than Aristotle had told them in the whole range of time past, so far as our inherited records show, no change appears to have taken place either in the whole scheme of the outermost heaven or in any of its proper parts. The model of the universe came with an underlying explanation. The celestial spheres were governed by a set of movers responsible for the motion of the wandering stars. Each of these wandering stars was thought to have an unmoved mover, the entity that makes it through the heavens. For many of the Greeks, this mover could be understood as a god corresponding to any given entity in the heavens. Now, I'm not saying everybody felt that way. The ancient Greek Aristarchus and others had said that the sun was in the center and the earth moved around it. Copernicus was developing ideas that would challenge the authorities had he allowed them to become public. Here is Giordano Bruno, defending his view that other stars out there also had planets revolving around them. They were little suns just like ours. The Earth was not the center of the universe, he said. Now, here is him the next day. The trial didn't turn out all that well for him. The morning after the trial, he's being burned at the stake. In fact, many people were beginning to question the authority of the church at this time and starting to point out that the emperor had no clothes. This is the way of science. As Thomas Kuhn described in his seminal work of history, The Structure of Scientific Revolutions, for years and years, people go on believing the same paradigm or another, even though some others are pointing out anomalies that don't fit that explanation. When too many anomalies pile up, a revolution, we've passed to replace the old paradigm. And so we come to the first image that destroyed the ancient world. Galileo discovered the telescope and used it to destroy a world, the ancient and medieval world of Aristotle, Ptolemy, the Earth in the center of the cosmos. This is a page from Sidereus Nuncius, the Starry Messenger, published March 13th, 1610. It showed that something besides the Earth, Jupiter in this case, had celestial bodies, the Medici moons, celestial bodies circling it. Only the Earth could do that for the ancients, but here, for everybody to see was an image that can be confirmed with the telescope that clearly showed that other celestial objects, Jupiter, had something like moons circling it. Something was terribly wrong. The ancients were wrong. The ancients, now remember, were the authorities, and order rested on their being right. Civilization, the world, depended on it. For some 90 years, the church, the authority of God on earth, had been battling the Protestants. And now the scientists also had the proof that the authorities were wrong. When the emperor has no clothes, the empire is in trouble. When the Pope has no clothes, the papacy is in trouble. The world must end. Now, I'm going to call time out here. I'm calling time out because, I'm calling time out because half of you are already racing ahead to figure out what I'm going to say next. I'll admit, okay, tell you the truth, nobody's actually going to destroy a world during this whole presentation. No world's going to be destroyed or anything like that. I just said that to get your attention. We're talking about images that force the world to change drastically. That old way of thinking, the old ways of working, because they no longer worked. Each of you know science and history. Each of you are experts in your own mind. What were the great upheavals in world history and scientific history? Which of these were triggered by science and perhaps inspired by images of the heavens? Think about it. Make up your list. Make your list and check it twice. What icons, pictures through the ages have changed things so dramatically that things really had to change? Ready? Let's go back and look at the rest of them. Now back to the regular program. Although in my opinion, Galileo's image of the moons of Jupiter were the most impressive demonstration of that the ancients were wrong, he piled it on in a lot of other images. By studying the size and shape of Venus, he demonstrated how that it moved around the sun. By watching how the terminator, the line between light and dark on the moon, he could determine that the moon had hills and valleys, hills as high as 4 miles high, in contradiction to the long-held authority that it was smooth. He was even able to draw sunspots, flaws on the supposedly perfect sun. All these images helped destroy the old world. Now, Tycho's observations could be used to improve the theory, and Nicholas Copernicus could publish his theory and people would listen. Kepler could explain how the planets moved. Eventually, Isaac Newton could explain why it worked that way. It would have happened anyway soon, but the timing was right, even though mankind as a whole could not see it. But often we see things only after somebody else has shown them to us. Galileo did that with his images of the moons of Jupiter, the phases of Venus, and the mountains of the moons and sunspots. His images had destroyed the old world. Earth lost its supremacy. No longer did the cosmos circle around the Earth. We were just one of many following the same rules, some rules that others had made up on their own authority. The Earth as the be-all and end-all was replaced, just as kings and the church were soon to be. The Earth was smaller, and it had lost its primacy. My other computer has gone crazy on me, so I'm going to have to talk to you by myself for a while. Yeah, it went real crazy. Bye, everybody. Okay. When the old ways of doing things would no longer work, we started having new ways of doing things. Democracy could come along because people no longer had to trust the authority, the king and the pope. They had to trust each other. They were important now. And when you get down to it, all these people here, they were no longer in charge because now we're getting ready for the next change. Galileo, Copernicus, Kepler, and Newton, bah, none of that stuff really works, okay? Because Einstein came along. And in 1905, he had a marvelous year. His miraculous year where he described so many different things of importance. But nobody took him seriously in 1905. He was, after all, just a clerk in the patent office. And it took a while before he became famous. 1905, let's look at it. The photoelectric field effect, he described that in one of his papers. He had 4 papers that were of fame here. The photoelectric effect started the quantum theory. So all this stuff you see nowadays about quantum theory comes from that first paper. Brownian motion, an atomic theory that explained why atoms seem to move around, why dust seems to bounce around the way it does. It was a theory of statistical physics. Special relativity. He reconciled the laws of electricity, magnetism, and motion. He proved that the speed of light is absolute. There was no luminiferous ether. He also came up with the most famous equation of all time, E equals mc squared. And he showed us that gravity bends light, or at least he tried to show us. We weren't paying attention, but he tried to show us. And from that, he also got nuclear energy. That's the basis for the atomic bomb and all the changes that it has brought to us, atomic power and all those things. All that happened in 4 papers in 1905, his miraculous year. He did not win the Nobel Prize in 1905 or 6 or 7 or 8. It wasn't until 1920 something, because nobody really took him serious. From 1907 to about 1918, he worked on his theories, trying to work them out so that he could make them all make sense. But nobody was paying much attention to him outside of a few astronomers and physicists and things like that. Nobody much was paying. He wasn't changing the world. He wasn't destroying anything. Here's the second picture, okay? This was the next picture. See these 2 little stars right here? Very important, these 2 little stars. They're not where they belong in a Newtonian world. This is a picture trying to illustrate what made Einstein famous. And it all depended on the lights all askew in the heavens. Men of science more or less agog over the eclipse of observations. Einstein Theory triumphed. The stars were not where they should have been. Okay? They sent expeditions all over the world to try to find out where the stars were, and they found out that stars that should have looked like they were here were in fact over here. Now, this is a prediction that Einstein had made. He said that unlike a Newtonian world where once something starts out, it goes straight, gravity actually bends the path of light. And so if a star is back here and sends out a ray of light this way, and it gets near a massive object, it'll actually be bent in its shape. And so somebody looking here back from Earth will see that star, assuming it's going in a straight path, he'll see it in a different position. So this is what an actual star field should look like if you're taking a picture of M44. You'll have 3 stars over here, 2 there, 1 there, 1 there, 2 over there. That's what it looks like. Unless there's a really massive object someplace right about here. And if you've got a really massive object right about here, this star right here is going to shift outwards. All right? Because as you just saw, the light that was back here hidden by the sun is going to look like it's coming from up here. Same thing down here. You can see it. We'll be looking through here. We can't see it through the sun because it's right here. But because the light has been bent, we can see it. Now, how do you see past the sun? Well, you've got to wait for a solar eclipse. Back then, you had to wait for a solar eclipse. So they sent people all over the world looking to see if they could find this solar eclipse. And they did. And this proved it. Actually, what's curious about this picture is that this is a picture from Brazil. Not from the actual, where am I going? There we go. This is a picture from another eclipse expedition that actually was more likely to prove that Newtonian physics was right. They didn't see this shift that was seen in this other, in the trip that I'm talking about here. So, this is the second picture that changed things. How did it change it? Well, in itself, it didn't change it. I mean, what it did was it made Einstein famous. And having Einstein famous, all sorts of other things could happen. Okay? Now, the third picture, the size of the cosmos. All right. This is, for those of you who've been keeping track, trying to guess what was going to be coming next, this is your third picture. It's a picture, if you Google the Great Debate. Oops, I've lost track of where I am. Now, it's a plate taken by Hubble from Mount Wilson, and he's picked out a star right here. And when he first saw it, he had never seen that star on any plates before. So he called it a new star. And he thought it was interesting. He kept studying, and then he found out that it was varying in brightness. It was getting brighter and dimmer, and in time, he decided, no, it's not a new star. It's a variable. Now, why is it important if it's a variable? Because variables help us tell how big the universe is. If you want to find out how big the universe is, the first step is to parallax. You can figure out the difference between here and here, pretty much, by looking at background stars and assuming they're staying in the same place. Measure where they are from here, and then wait half a year and measure them from where they are and there, and you will find that this angle, the angle out to the far stars, change. And using trigonometry, you can apply and figure out how far away this group of stars is. That's called parallax. But parallax doesn't work for very far, and it's hard to figure out some of the basic assumptions. So there are other ways that you can find out how bright something is. These are candles, and you'll notice they're all the same brightness because they're all the same size candles. But as the further and further away you get from them, the dimmer and dimmer they get. As a matter of fact, scientists by now had figured out that when you double the distance to a candle, the light from that candle is spread out to double times squared. So it's spread out by 4, which means that it's 1/4 as bright. When it goes out to 3 meters or 3 parsecs or 3 whatever it is, it's going to be 1/9 as bright, 3 squared. Okay, so they figured that out. But Levitt Swan came up with the rule. She was looking at a bunch of these stars. She was looking at a bunch of Cepheid variable stars in the Large Magellanic Cloud and the Small Magellanic Cloud. Now, what's curious about these things is that they're all approximately the same distance away. And she figured out that the brighter one of these stars got at its maximum, the faster it would go from bright to dim. Okay, so she figured out a relationship between the brightness and the period of the dimming. Now, if you can find a star very far away and you measure how fast it's dimming and brightening, you can now know what its absolute value is. That way you can tell what the standard candle is, how bright the measurement should be. And that's what happened. Now, when I was a kid, we weren't rich. We were a nice family and everything, but we were cash poor. We didn't have a lot of stuff. And a lot of the books that I read were hand-me-downs. People would give us books. I have over in my library here a 1926 edition of the Book of Knowledge. And in that Book of Knowledge, they described the Andromeda Nebula. Okay, the Andromeda Nebula is not the Andromeda Galaxy. It's the Andromeda Nebula because they didn't know it was a galaxy. If you look up the Great Debate, back in 1920, they had the Great Debate. And Shapley and Curtis were arguing with each other. Now, both these guys made a lot of mistakes. They were arguing about how big the universe was. And one of them says that all those little fuzzy things you see out there, they're all part of the Milky Way. And the other one says, no, they're out there. They're island universes. They're far away. And what this picture does is it settles the debate, because when Hubble measured this picture, when he measured the variable in this picture, he found out that this thing was very, very far away, so far away that it couldn't be part of our Milky Way. So the old Earth was destroyed. The Earth, remember, once upon a time was the center of the universe. And now it's a teeny weeny little thing circling a star. The old Earth has been destroyed, and it's been destroyed again by being shrunk down to minusculity. It just hardly exists at all. But Hubble wasn't finished destroying worlds. He kept measuring them. And here is the fourth of our magic images that destroyed the world. You can see that Hubble continued to find these variable stars in other galaxies throughout the universe. And as he started to measure them, he would find out that they were further and further and further. Well, they had different brightness levels and different distances apparently, but he noticed something else about them eventually. He started studying their wavelengths of light that came back to him, in particular hydrogen. Now, hydrogen gives out a peculiar characteristic of light. When it's on Earth, it gives out light waves that are in X position, and in a given position. 78,000 light years away, those same lines are found at a different wavelength. And the further out you go along here, the further you get a shift in those wavelengths. Here is where you would see it at 78,000. Here's where you'd see it at, what is that, 1 billion? And here's where you'd see it way out there. Now, what could be causing the light to shift to red? I think we've all been around when a jet's come by. Here comes a jet. It passes us and it goes. The sound of the jet changes. And that effect is found in stars, it's found in light, it's found all over the place. We observe in light, we observe a redshift, whereas in sound, we observe the Doppler effect is what it's called. We observe it in the sound where it changes pitch from high as it's coming towards us to low as it's going away from us. So Hubble charted all this stuff. And he found out that the further something was away from us, the further away it was going. Now, what does this mean? Well, this means that everything is trying to get away from us. Nobody likes us. Remember, we used to be the center of the universe. The whole cosmos was dependent on us. We used to be a big place. Okay, maybe we circled a sun, but that sun was important, wasn't it? Hubble says in the first place, we're teeny weeny. The universe itself is huge. These stars that I have found show that the Andromeda galaxy is a separate galaxy as big as the Milky Way and bigger, and there are billions more out there even further away. And then he piled it on, destroying the Earth even further by saying, everything is running away from us. Nobody likes us. We're not only small and insignificant, but nobody likes us. Everything's expanding away from us. And other people got a hold of it and traced it back and found out that, yeah, once upon a time, we were all together way back then. And sometime in the future, we're just going to keep getting further and further and further away from each other. So we're not at all what we thought we were. It's still home. You know, it's a dismal presentation so far. We've been getting from being the center of the world, the center of the cosmos, to just a nothing. But all that changed. Okay, all that changed in 1968. Earthrise is not the only version of Earthrise. This is Earthrise, but there were other pictures taken of the moon coming up over the side of the horizon, the lunar horizon. But Earthrise, for some reason, really caught, and it is probably the most famous image in the world. It's the last of our images that destroyed a world. The world that it destroyed was an insignificant little speck that wasn't anything. But Earthrise changed it into someplace really important, someplace that we got to take care of. Now remember, this is the time of the Love Canal. This is the time where Santa Barbara had oil spills. This is the time where the Erie River lit off on fire. 3 Mile Island's happening. And wait a minute, this is our Earth. We got to take care of it. It's a beautiful little place. Life, remember they chronicled the history of the world? All right, every weekend we would get a Life magazine, and they took pictures because we didn't have televisions early on in that. Eventually we got the televisions, but we still, Life and Look magazines really told us they were our news magazines. Time puts Earthrise on the history of our world, and 100 photographs to change the world for Life magazine. I don't know how many of you guys can remember this, and I feel like, you know, boomer explaining it to everybody, but this is the only catalog ever to be recognized with a National Book Award. It's the Whole Earth catalog. If you were to Google nowadays, how do we treat the Earth better? How do we save our resources? How do we get along happily with less? Back in 1967, 68, 69, this is the book that you would have found, okay? They didn't have Google back then, I guess you know by now. This was the most famous. Rowell, who is one of the great nature photographers, calls it probably the most influential environmental image of all time. I mean, it is one of the great images of all time. And it destroyed the insignificance of Earth and made us all care a whole lot more about it. And this is the famous pale blue dot taken in the same spirit. Carl Sagan describes it, he describes it much better than I can, as the pale blue dot. These are rays of sunlight, okay? And he tells us that everything we've ever known, every criminal, every holy man, every politician, every one of us, everybody we've ever known, or, you know, that's where they were. That's where they are right now. Just taken from way out past Saturn. Looking back, and we see the Earth. And that's how Earthrise destroyed the insignificance of a little world. And that, folks, are 5 images that I hope you take with you as seminal images. They changed the world, destroyed the old one, and brought us something new. Thank you.
Thank you very much, Alex. That was an awesome talk. I hope everybody enjoyed that. I have not seen any questions in the chat. If anyone has any questions for Alex, please, I guess you can go ahead and just unmute and ask, since we're not, no point in typing and then have somebody else read it.
Yep. Thank you, Alex. Great presentation. Curious on the, you mentioned in the Einstein photographs, looking for and the eclipse. Were there many missions, or kind of, you know, were there multiple groups going after this? Was it just one?
No, this was something that they theorized about doing back in 9, 10, 11, 12. Okay, they decided that it would be important to get all these people out doing these things, and so they tried to organize it, but there's this World War going on, so it was difficult to do, and so they had to put it off. They had to put it off. So there were organized expeditions going all over the place, but this was the one that made it famous. That particular picture.
Thank you.
Do we have any other questions?
And folks, feel free to come off of mute.
Yeah, please.
Yeah. Well, while we're waiting for anyone else, I have another question. The mammoth carving was, you know, I'd never heard of that or seen that before. What specifically is that? Is that a particular relic, or known as a particular relic?
Yeah, we're talking about this back here. Yeah, it was found in Germany, and let me get back to sharing my screen a little bit. Yeah, it was found in Europe, Germany, and I am not so sure that a lot of people agree with the interpretation of this particular scientist. He explains it in so many different ways. You know, if it is something, why don't you let it be that something? How many different ways can you explain it? And the fact that it's a pregnancy calculator as well as everything else, I don't know. I've got more information on that. I don't have it in my head, and I don't think it'd be appropriate right now to go into it. But if anybody gets a hold of me, I can give them more information on where I found that stuff. It's 35,000 years old though, so it's up there.
I have a question. Did Orion look more or less the way it does today, 35,000 years ago?
No, that's another whole thing. Actually, it takes more than 35,000 years to change Orion. The belt stars are moving around a little bit, and things will change. I got another slide presentation where I do go through the changes of Orion, and that's 100,000 year thing, and even then it still kind of looks. Besides, what is a giant? What does a giant hunter look like?
Right.
He's got stars. People make things out of anything up there. I'm not sure that they're accurate. There can be a lot of reading things into these images. So
Mike, I can put a picture up about Einstein expeditions.
Okay. That got garbled.
Sorry, Steve.
On the chat, I just put up a picture of the cover of a recent book about the Einstein Eclipse.
Okay. Yeah. It was very popular because it just happened in the last year. Oh,
thanks, Steve.
Centennial of it.
Can I follow up with a question?
Please.
You good? Yeah. So thank you so much for that talk. It was fascinating. I was 1 for 5. I guess.
Oh, yeah. What
So
did you have?
Well, once I realized what you were doing, instead of the prettiest pictures or whatever. No, I had the last one. I had the Earthrise was what I assumed was coming up.
Okay.
So really cool. So if you had to just put $5 on it right now or whatever, what do you think what's the picture we're waiting for to change things again?
Aliens.
The first UFO. Come on, say it. Say it.
That would do it.
That would definitely change things at first actual contact.
Do you think it would be a picture of something that is just indisputably life? I mean, I'm not talking about Mr. Spock coming, but I'm talking about some clear, bacterium and Enceladus or something like that.
I think life.
Yeah.
If we were to see some biological life someplace, that would have to change something.
Mm-hmm.
If it were intelligent life, ET, yeah. And if it were, approaching us in a battle wagon, yeah. Hey, let me ask you a question. You guys can all respond to this. I don't know how Zoom works as far as this goes, if in chat room or anything. Everybody got the first one, Galileo. Now, for the other 4, how many of you got all 4? How many got all 3? Got 3 of them? All right, then what did you put up there instead? You got 3? Okay, cool. What did you put up there instead?
I gotta say, it was. I'll jump in and say I had a hard time. I did get Galileo. I got Earthrise, and it wasn't until the Einstein one I was trying to think of the double slit experiment. I go, well, I know he measured something, but I don't know whether. So
yeah, well, that would have done it, except that it's Astro Images.
Yes.
Okay, so yeah, okay.
I'll just say I thought that at the beginning you actually showed the cave drawings from LaCaw. I thought that was actually trying to change perception when someone actually realized that the cave drawings of LaCaw were actually an astro image of the heavens of 10,000 BC. I mean, to me was perceptual changing, because for so many years people thought that the Earth was much younger, and then that would have actually kind of nailed it right there.
Okay.
Well, I would think the Michelson-Morley experiment was actually astro imaging.
Really?
Yeah, because they were looking for the ether.
Yeah.
It's supposed to go through it, so that's a different kind of imaging, perhaps. But similar to the gravitational wave experiments. So maybe
Yeah.
maybe even the chirp diagram from the gravitational wave might be a
That's a
The
good one.
yeah, the gravitational lensing stuff is going to be interesting, or not gravitational lensing, um, the
Yeah.
LIGO.
Yeah, the LIGO wave. Yeah.
Okay, so do you call an image taken with a radio telescope a photograph?
I call it an image.
So is it astrophotography?
I don't know. Define.
It's not using images.
I remember I spent the first, I don't know, however, a minute or so defining what I would count as an image. So,
Right.
yeah, I don't think there is a single.
Radio waves aren't visible, so it's not technically
Yeah.
it's not a picture, it's not a photograph.
Radio waves aren't visible, did you say? Or
Right.
Oh, okay, yeah.
The camera captures visible light or near visible light, whereas a radio, but you can get into the infrared, which isn't visible light, but it's still a photograph of light.
Mm-hmm. And I've seen beautiful nature photography with infrared light.
Yep.
And I can't see the infrared light, but boy, Yosemite in infrared is really stunning.
It's amazing. Yeah.
It's always stunning anyway. But
We should just put a post out there on cloudy nights, and they'll be easily able to define
Actually,
what.
I did. Before I wrote this presentation 2 years ago for Sequoia, and I did ask what are the 5 images that changed the world, and this list was pretty much in there. What I got also in addition to this was a lot of the stunning Hubble photographs that everybody looked at and said, "Oh my God, how beautiful!" But remember, I disqualified beautiful alone as influential.
Yeah.
Right.
Agreed.
I think an interesting way to think about that might be what's always amazed me, and I'm not an imager myself, as people know, I'm a strictly visual guy for the most part, except for cell phone pictures. But is the simple fact that now guys in the club from their driveway can take pictures that 25, 30 years ago were only available by like Voyager probes. So it's not one sort of image, but the very fact that that amount of knowledge and detail is available to common people, and now people with $1,000 to $2,000 investment can actually do real planetary science, I think is
right.
revolutionary on a small scale.
Yeah, I've got a meteor camera every night tracing all the meteors that come over my house, and they go back to a big database and they figure out where the meteors are coming from and all that other stuff. And people are finding. I've got a buddy that's finding exoplanets out at Goat Mountain right now. Well, when it gets dark tonight, he's finding exoplanets with his amateur telescope gear. So we're doing that stuff. Oh, what's in chat?
I think it's amazing the amount of people in the public that just assume professional astronomers have eyes in the skies, that every square inch of the universe is being monitored by all these amazing, telescopes and things like that. And the reality is, there just aren't enough. And when you look at what the amateurs can do in terms of, being able to switch over and capture the latest and greatest phenomenon that is, we got a supernova. It's the amateurs that can actually slew over and catch those, faster than pretty much anything, professional, because the time's already allotted, time's booked.
Mm-hmm. Well, what a lot of professionals are now doing is they're getting a hint as to what's happening in the professional world, and then they've got a network of amateurs that they can immediately email and ask them to change their observing program to gather more data for them. Mm-hmm. So if LIGO sees a disturbance in the ether, it will have 400 amateur astronomers around the world looking at that area, trying to figure out what it was.
Yep.
Although I guess they wouldn't call it a disturbance in the ether, would they?
Sounds good.
That would be the force, a disturbance in the force.
Okay.
I have a question about a minor detail.
Okay, do we have any other questions for Alex?
I have a
Yeah,
question about a minor detail in your talk.
Okay.
Go ahead, Robert.
Do you remember the date of that Einstein clipping from the New York Times? The exact date?
Not off the top of my head. April 19th, was it? Beep, 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 beep. Where is... I've got them other places. I've got more extensive notes on all this. So I just don't keep them right here.
I just thought you might have it off the top of your head.
No, I don't. I'm not sure if it was even from the New York Times. What makes you think? Did I?
The typeface looks very much like the New York Times.
Oh, okay. And it could be. I just don't remember. But it's. I mean, all you got to do is Google images for that, and you'll find it. Or you should find it.
Okay, thanks.
November 10th, 1919.
November 5th, was it? Okay.
1919.
I thought he said November 10th.
Yes, November 10, 1919.
Thank you, Steve.
Yeah. Yeah, we just passed the 100-year anniversary, so it was in the news lately. But what amazes me is we've just passed the 100th anniversary of well, we haven't even gotten to the 100th anniversary of finding out that the Andromeda galaxy is a galaxy. That's surprising to me.
It's amazing what we've learned in the last 100 years. If we keep learning at the pace we're learning, hard to imagine what we'll know 100 years from now. All right, if there's no more questions, I want to thank Alex again for his really interesting presentation. Thanks for joining us at RAC. Hopefully,
Thank you, Alex.
join us again in the future, and you're always welcome to our meetings.
Thank you.